I guess it's time. It's 11 o'clock, right? Let's go ahead and check. Yep, it is 11 a.m. Central Time. For those of you, of course, on the East Coast, it is 12. And let's not forget the Pacific Coast, which is 10 a.m., right? Am I right? No, 9 a.m. It's 9 a.m. over there, isn't it? Either way, as you guys know, I am none other than Fusion Phil. If you are new to this channel, we provide a free support Friday anytime I'm at home. Now, next week, as per if things go through, Matt in the chat has alluded to his company is looking to send me out his way and do training to get those guys all off of Mastercam and into Fusion. But other than that, we are trying to be here as much as we can for you guys. And again, if you're new or returning lovely customer of ours, at any time, if you guys have questions, I do have chat pulled up, as I can see Joseph out there. Great to see that you made it once again. But you could ask questions at chat anytime. You could also use the support email down below in the link or in the description of this video, and you can send in parts and auto-generate tickets. Now, there's no guarantee I'll get to it. However, we like to try our best and simplify and make these problems readily available for everyone. With that, Matt has actually reached out to me and hit me with a good old problem that we're going to start out with today. Now, guys, go ahead and let me know. Can you hear me all right out there? Any issues with my audio, things like that? Fourth Axis Haas machine. Well, great to see you as well. So, Lester, are you new to a fourth axis altogether, or are you asking machine sim questions? In the meantime, I'm going to go ahead and swap my screen over here real quick, and we're going to actually start a brand new file because I am going to model what it is that Matt brought to my attention. And I'm not kidding you guys. This was maybe, what, 5-10 minutes ago. What he has is a very specific kind of profile on a part. Now let's go ahead and give this some rough dimensions. And once you guys see this, I think you may or may not be able to paint the picture of what this could be. And we're going to throw another rectangle kind of around everything here. And that's going to be a little exaggerated. So let's bring that down. Let's get this guy brought down and extrude our profile. So on something of this nature, now there is a gap up there. We're going to have to fix that. There we go. The issue is undercutting inside of a part or a profile when machining. So as you guys are going to see here is in the specific use case, there's something that he is making that supposedly rhymes with rock, that it's very important that you get in and machine out these undercutted profiles. Now, I may be wrong. I don't think it's rhyming with rock. I think it rhymes with something else. Let's get into our manufacturer side of things. As you guys know, we're going to go ahead and do our Z axis. Let's put X in the right way just because. And then with that, we're going to start to attempt this with a couple of toolpaths. I am going to fix my setup just because it's going to be much easier to generate my stock model as we work. Now, the question is he was concerned about using a parallel toolpath with 5-axis. And with that, we're going to go ahead and we're going to start with the basics, which is let's get our toolpath basically where we want it. So I'm going to go ahead and select the tool. Now, whether or not you're using a ball end mill on your guys' end, that's going to come up to you. Now, I am going to actually have to pull one from the default library. Get us a smaller 1/4-inch ball end mill here. I'm going to swap out the holder once we get everything set up. So again, we're going to go back from there. Let's go ahead and get that tool stuck out. Give it a end mill holder. We should have something in here. So give me a few seconds here, guys. That is not going to work. We're going to need something that's kind of like a long extension. I think this is the one I'm looking for. There we go. A little better. Now, the idea right out of the box, we're going to go ahead and hit OK and get a tool path. But as you guys can see, as of right now, everything is still in 3-axis mode. So I'm going to go ahead and shift gears and let's step up the capabilities here. Now, what I'm going to do is go to 5-axis. Now, we could use vertical, and what vertical is going to do is it's going to keep our tool pointed vertical as much as possible until it can reach underneath or it starts to hit that tool holder. Now, the problem with a strategy like this is because it is still defined as vertical, it doesn't know anything is going to happen with undercutting. So a few more things I might need to do here is, as you guys will see me walk through here, is utilizing a different strategy Now, this is where we get into our actual different types of control for primary tool access. One that I would recommend is we could either go from curve, which would be very, very valuable, or from point. Now, the reason why I'm saying from is because on this particular part, we are working in a female or like a negative side of a cavity, right? So we want to always keep our tool from a specific location. So let's go back. Go into our design. I am going to clean this up a little bit because from what I remember, this top is actually much lower. Again, just making it a little easier when we create our tool path. As you can see, that's now done. And I am going to create another kind of plane to work from. So now where you put this plane at the end of the day will make a pretty big difference. But I'm going to go ahead and create my construction plane. And I'm going to place it on the top of my part because I can move that plane at any time. And upon moving that plane, we'll move the sketch that I'm about to create, which is going to be nothing more than a line down center. So as you guys can see, that line is up there in space. If I go back to that construction plane and I pull it up higher, what's going to happen is that line is now moved up higher. If I pull that plane down lower, you're going to notice that it brings that actual line down lower. So again, this is a neat little trick, especially if you're doing some 5-axis stuff. So let's go back to manufacture. Let's get into our toolpath and swap out our primary mode from curve. And then our curve is actually going to be that line right there. So as you guys are going to see now, up on the top, completely useless as you guys can see. But what is going to happen is once we start to get down underneath and starting to machine things. So again, we could make some more adjustments here. If you guys didn't know, this is where we could go in and select our boundary. Now our boundary could be based on some of these profiles, but because we have overlapping in the corners, I don't know if you guys could see that, it's going to really shrink down the profile we're working with. So this is one of those very few type of situations where staying silhouette, however, doing an avoid surface kind of selection might be beneficial to you at the end of the day. So what I'm going to do is we're going to go ahead and say avoid surfaces, and we're going to generate that tool path back. Again, now we are inside of that cavity. And if I was to simulate this, let's get squared up to our part. You're going to notice that my tool axis right here where this little point is, might be actually a little tricky. Let's flip sideways. That is the center line of where my tool is calculating from, right? Yes, I know we're crashing the machine right now. Not a big deal. But that is what's determining as we work down and back across the part. I'm going to go ahead and hit play here. And we might have to adjust a couple of things. Let me get my accuracy turned down a little bit. But as you're seeing, that tool is slowly stepping around, almost like a clock, right? That minute or second hand on a clock, we're working around, always maintaining center line of that actual edge. Now, this is where it gets better, because if I go back to design and I lower said point, what you're going to notice is when we're in the manufacturer workspace now, that tool path is going to tilt further and further and further out. Give me one sec here, guys. I got a little bit of a itchy nose going on. It is a good time for me to tell you that if you guys are liking this content, feel free to buy me a beer, buy me a steak, sign up for our trainings and things of that nature, which I'm going to jump back now and crack open my lovely energy drink, because you guys know I'm not going to drink a beer on stream. I might have to save that for Twitch or something, right? Now, I am seeing Matt out there hassling me in chat. Give me a sec here. Let me get caught up with the chat and everything. I need to know. Okay, Lester, we're going to get back to you. What about doing it the other way? What would I want for the curve? Oh, it looks like you're doing it the right way. Yep, 100%. So I figured you wanted to run down that surface. Now, at this point, again, one cool thing is if I was to change my pass direction to horizontal across my part, same rule is going to apply. We're going to swoop back and forth inside there, but it's simply just going to, again, constantly maintain the center line of that tool. So as you guys can see, she's just rocking back and forth. Again, we want center line of tool to intersect with the line that I generated. So as you're seeing, if that line gets further and further down, Now, there is going to be a point where we actually need that line to be at a minimum tangent off our circle, but also I am going to fix our tool here real quick. So give me a quick second. We're going to go in and I'm just going to pull that end mill out a little bit longer. Let's say 2 inches. And then with that, let's go ahead and jump back to the design side. And we're going to, again, bring that actual plane down further. Now, if you get too far down in here, the rule still applies. We got to worry about the back side of the tool versus the front side of the tool. And I will have to actually take off past direction. And just like that, we're starting to wrap around a little bit more. But the real problem is going to arrive at the fact that this is a 3-axis toolpath. This is not a, actually, I shouldn't say, it's a 3-axis toolpath with the ability to do 5-axis. Now, this is where you may want a completely different strategy to do undercutting. Now, a couple of remedies to this would be is instead of doing 5, we may actually want to go through and do this as 3 and do tool orientation. So again, as you guys can see here, I'm going to go ahead and use my good old-fashioned steering wheel controls. But if I was to tilt and turn that tool, as you can see, again, I could start to achieve more things, getting further and further underneath of where that profile is. I'm still limited at the end of the day. I still need to, again, possibly go in, add additional faces to my avoid grouping possible. Again, let's get this. And lastly, let's tilt our tool just a little bit more. Now, I am going to switch strategies here because I think there's going to be a better strategy overall to utilize against a part like this. And what those strategy would be is getting into steep and shallow. And then from steep and shallow, I am going to force steep only. Now, the reason why I would do steep only is because it allows me to machine undercuts. Now, when you're using a lollipop cutter or 5-axis, it will actually look at anywhere that it does not have accessibility. Again, this is a pro tip for a lot of you guys out there is if we go ahead and turn on 5-axis, and you can turn on tool axis or tool orientation without ever actually needing to define a different direction. But what's neat about this is you can actually do an accessibility analysis in real time. So as you guys can see here, if I go 90 and start to tilt the other way, notice how it's actually showing you the exact surface that you're going to machine, right? More tilt, less tilt. Again, this works both ways. Again, I keep saying again today, guys. I get into these things and I get so excited and nervous and I just keep repeating things. But let's get back to it. So we're going to go ahead and turn off tool orientation. I'm going to leave ourselves vertical to start with. Again, let's just get a tool path on the part. As you guys are seeing, we're not getting underneath anything. We're also got a lot of extra stuff going on. So let's get the blue lines where we want them. Machining boundary is silhouette, tool center. Again, we're going to go ahead and go. We actually probably won't need to do any of the fancy avoid touch surfaces. But Matt, let me know what you think. So this is kind of the strategy you're going for with going back and forth inside there. Now, again, with the steep and shallow strategy, we could utilize 5-axis. We could then go lead and lean, or again, from curve, picking that line that we have. And as you should see, we're now wrapping down, under, and all the way through. Again, still dealing with collision avoidance. There's a lot of little nitty things that I would have to go through, but this is where we could get even more and more fancy with this. I'm going to turn off the linking so you guys could just see the toolpath. But if I go back through here a little bit more, let's say we actually do steep and shallow this go around. However, we're going to do parallel. Again, you could do parallel on fixed direction. So we're using contour in the steeps, parallel in the shallows. And what you're going to see now is, again, because we lost the undercut ability, we're not getting all of that in one shot, right? So this is something that Fusion, again, takes a little bit of time and effort to start to work through and figure out what's going to be your best solution. But what's happening right now is everything is being calculated from tool orientation Z, right? So it's not going to drive the steep versus the shallow based on the exact location the tool is pointing. It's all still generated coming straight down in Z. So again, if it was me, this is just my take on this, we would go ahead and utilize steep only, machine undercuts. Again, you're now getting that undercut area. And for those of you out there that don't know, technically the bottom on this use case, there is a giant opening for a certain particular item to come up through. So Matt, I'll give you a few seconds. Let me know how that looks for you. For the rest of you guys out there, feel free to ask questions at any time. I see Lester went blasting through here real quick. Need to know how to make the 4th axis angle modal in my post. Okay, using the Haas Next Gen inspection post. Lester, are you using machine definition at all? Because that is exactly where I'm going to point you to. Whether or not you use machine simulation will make basically all the difference or none of the difference, but the machine definition is the important part. So what I'm referring to is if I go in and I select a machine. Now, as you guys know, we, of course, after this, we eventually delete all of our machines. But what I'm looking to go for is either I need to go to the Fusion library and find that Haas machine. So again, as if we filter by Haas. Now, what machine is it exactly, Lester, Haas, that you have? And what rotary do you have, if you don't mind me asking? So we'll give you a few seconds. Let me get another drink here. Get my nose scratched a little bit. VF2SS. Awesome. So there is a ton of different machines inside the Fusion library. As you can see, there's a VF2TR. There's a VFT with a HRT to 160. So you have an HRT, not a TRT. Now, sometimes it's easier just to search by HRT. Again, you're not going to possibly find your exact model. Now, this is where, again, if you guys have our support package, we have no problem putting together the correct actual machine sim for you to utilize, right? Now, if you're just wanting to go out and post some simple 4-axis code and you're not worried about machine sim, what I would recommend is that is where you could start by just building your own machine. So as you're going to see, I hit the plus here, pops out this window. We're going to go ahead and call it the Haas VF2SS. And then I love to throw a width HRT 160. Don't really need that generic description, of course. Now we're going to go down to the kinematics area because we need to order our axes based on how they stack up. For example, the head of your machine or spindle sits on Z. Your X actually sits on Y. And then here with X highlighted, I'm going to add a rotary axis. Now your rotary axis in itself, a few quick tips for you guys. If you do not have dynamic work offset and things of that nature, we're going to go ahead and turn off TCP. Now, another thing you may want to do is either go unlimited, limited, or cyclitic. Cyclitic is going to take whatever the dimensions are divided by 360 in this case. Or again, most 4 axes are unlimited. This is a really good point for any of you guys out there dealing with a gantry 5-axis. You can't spin the C axis unlimited. You actually have a limited range or the B axis tilt. But from there, we're going to go ahead and throw a post processor at this. I think I have a completely broken Haas Next Gen post. I am going to update this post to delete any types of problems I have in the background. But just like that, I have now tied the machine or the post processor to machine definition, and machine definition is controlling that. The value of this at the end of the day is if you are in a shop and you are responsible for programming multiple different machines, is when you tie the machine to the setup, when you go to post-process things, you don't have to worry about making sure you selected the right post processor. You can also change the output folder, which is extremely handy. So as you guys are going to see here, what I'm going to do is let's go ahead and make this a full 4-axis. And as you're going to see here, guide curve cannot use. So we're going to go ahead and turn off guide curve and say 2 rotary axis. I think we're going to get a lot of problems with what I'm trying to do here, but we could go ahead and switch tool paths into tool orientation. Now, something neat, as you're seeing, again, with machine defined, it is telling me that certain things are not capable. So again, we'll just go with the basic facing cycle. Let's go ahead and go into my templates. Boom, there's facing number 1. We're going to duplicate that. Tool orientation, Z this way. Your A axis does actually require to be pointed in the correct direction as well. But if I was to post-process this out, Lester, I think you're going to see here, you're going to get exactly what you want, which is going to be your A0 command and then your A negative 90 in this case based on my tilt. Now go ahead and let me know how that is looking on your end, and is that what you're looking for? Again, we'll give you a few seconds there to answer. I know a lot of people are starting to show up, disappear. If you have questions at any time, feel free to utilize the email down below if you want to submit a support ticket, or if you want to ask that question live or have additional questions, feel free to at any time. Let me go ahead and get things moved around again. Hold on here. Woo, man, give me 1 sec, guys. I'm going to get my nose blown out here. All right, I'm back real quick. All right, so please create another negative 90-degree operation, and let's see if, okay. So do you want me to go about the palette situation? Are you running first setup out of a bar, or are you running individual blocks on a palette? Man, I don't know what happens to me. Every time I come in here to go ahead and start these free videos and everything for you guys, my nose starts going wild. Lester, we'll give you a few more minutes to answer. I'm going to go ahead and just create both of them just to see. So again, we're going to go ahead and flip our tool orientation down now. And one more time. And I'm going to actually visit this issue that I'm having. There we go. So you guys are seeing I'm getting this warning, and I just want you to know the reason why I'm getting this warning right now is because I made my stock the exact same size as my part itself, right? So again, because of the parametric recognition of my heights tab, stock top right now and model top are the exact same dimension. All right, just duplicate the operations and post. Sure, no problem. So let's go ahead and post process. Again, post it out with all 4 sides. So we're starting now at A0, a negative 90, a negative 180, and then a negative 270. Now, if I reorder these, we might get a little bit of a different result here. So again, let's just go ahead and go from 12 o'clock, 3 o'clock, and then 9 o'clock. Now we're getting A0, a negative 90, and then we're getting a positive 90. So again, as you're seeing, is it's going to calculate basically the shortest distance, either crossing across 12 o'clock or the next one that's coming up based on your toolpath ordering. I must be having an allergy attack here. Lester, I'll give you a few more minutes. Travis, still waiting for a response from you on the other. I need 2 negative 90 degrees to see if it's possible. Oh, see if it posts the negative 9. Okay, I see what you're saying. Okay, so if I duplicate, so again, what we're doing now is we're staying at the same tool orientation when I post process. And what's going to happen is again, as he's requesting A0, a negative 90, but then the second facing operation does not have anything on it for a position, because currently right now, Fusion thinks you're still at that last known position. Now, this leads me into a pretty good point for some people is in the event that you actually wanted to pick up and run from a specific operation, there is a setting on the next gen controls that allows you to turn on program lookback. Now, if you don't want to do that, when you go to post-process, there is a option to safe start all operations. So by turning that on and reposting this exact same code, what you're going to notice now is, again, A0, we have block skip, abilities to skip over any detail, a -90, and then when I scroll down here further, again, because safe start operations is turned on, you're going to see block skip G0, a -90. So as you guys can see, again, nothing more than a little checkbox for safe start operations. It's going to basically take every operation that you're doing and generate that with all pertinent information to that specific one. Now, something I will point out too is I'm still seeing G254, G255. That is the dynamic work offset or tilted coordinates plane. Again, there's a lot of names for it. When you're posting out, even though I turned it off in Fusion on the machine, I may need to go to my configuration of my machine. And if I can find it under the multi-axis tab, turning off TC, PC, as well as DWO. So again, as you guys are going to see now, we're going to get no G254. We're just getting our standard, good old-fashioned callouts as needed. Travis, so my question was for you is you said you're running a pallet of parts. Are you running the first setup out of a bar or are you running all of them individually? In the meantime, let's go ahead and shift gears here a little bit. I did get a question. Will, if you're still out there, Will messaged me early, or actually late last night. And basically with that, he was having some issues of tool breakage on his part. Now, again, upon some review, I need to remember where he was having those problems. And this is actually where he was having those problems nonetheless. So right now, he is trying to utilize, in this case, he's got scallop to clean out the material here for this fishing lure. Then he's going into a ramp tool path, and he's ramping downwards. But what I looked at, and the reasons why he possibly is actually breaking a tool, is if I just click through some operations, you can notice from tool 5 to tool 10, there's a lot of material being removed. But with that being said, is the difference in the overlap of the two tool paths themselves. So as you're seeing, is we have that ramp tool path getting down there in a little bit. And again, he's doing a tool change from tool 5. This is a 0625 into a 062 quarter or 1/16th ball end mill. But this is where I think I would change what strategy I use, right? So I'm going to go ahead and steal his information and we're going to jump over to, again, steep and shallow. Now, the reason why I like the idea of steep and shallow here is, as you guys will see, is I can basically merge down both of the tool paths he was trying to do. Again, we're going to have to drag this back up to the top, I have a feeling. Let's get it back up here with everything else. And with that, we should see a tool path, and we don't, which leads me to believe that something on my end. Go ahead and regenerate. And let's see why we're not getting a tool path. Do we have rest machining turned on? We do not. There is our tool containment. Now that tool containment in itself, I also did point out the fact that he may want to go a little bit further out with that information. But for some reason, I lost all my tool paths. Did we just find a bug or did I push F7? I pushed F7, chasing my own problems. But as you guys can see, this is something that I think would be night and day difference on a location of machining like this. Is, again, that scallop toolpath you can see is only in the bottom. You can see that parallel toolpath he's kind of only got at the top. He's also using two different tools. But if he was to go in with something like steep and shallow, he does have that ability to go horizontally across, working his way down. And then when he gets down into a lot of these lower regions, we're starting to pick up on utilizing, again, scallop for the shallow and contour for the steep area. Now, a few other things that I usually do recommend when you're getting into a tight little working area like this is the amount of material you're leaving on the walls makes a large difference. Again, I just want to show you, if you guys didn't know, if I go in and I try to simulate this, as you're going to see, is if I push play and let that run, again, we're going to get down inside that cavity. But now you can actually go through and you can inspect stock to model, right? So if I put my mouse right about here, you're going to notice I have 027 material. Again, getting a little higher, 030. Now, if I zoom in a little bit further, you're going to notice that my graphics card kind of falls apart, but that's what we're looking at in that tiny little region. So the reason why he's possibly breaking end mills is at some point he's going in and slotting to remove material with those ball end mills. And that is where I would, honestly, that's where I think the tool is breaking. I'm almost more than certain about it. Now, another thing I did notice, I'm going to go ahead and jump to his next tool path here. Give it a sec. Is this very first path he makes, if you notice, he's plunging down, and now he just plunged into that corner, right? So he smashes down. I don't know how close I'm going to get without turning the accuracy up here. Again, plunged. He's already touching this back wall as well. And then as he comes across this very first surface, you're going to notice that he's going back up, over, and then bam, plunges way down in there and loads up that tool. So again, this is something that is probably causing that tool to break at the end of the day. So again, as you're seeing, that would be where I would start to point my finger. Again, where that tool is breaking is because you're loading up that tool in this corner when there's still material there in the way. So again, it's kind of hard for me to get back. I don't know if the model's going to come back through very quickly. We'll give it a few seconds here. But yes, overall, what I would recommend is if this is something you're planning to do, very first thing I would do is, it looks like you roughed out that pocket with a 1/8 inch end mill. I would in some way then go and transition. So it looks like you come into tool 5. So I would actually come off of this tool path. Again, I just duplicated, swap out to tool 5. There it is. And then utilize rest machining to eliminate where I can and cannot go. So I think you were set to a stock of 4 thou. We get rest machining turned on from previous operations. We want to ignore stock less than 20. Let's go 25 thou and see what we get. As you can see now, Fusion has automatically picked up on what is still left to be machined, which is at least getting me into some type of roughing in that corner. But it's not good from there to jump in and try to do other additional things. Again, this is where we might actually have to go one level deeper. Again, duplicate. We're going to go ahead and now go to an even smaller tool. As we're going to see is we have a 031 flat here now. And let's see what we get. So again, anytime I can open that pocket up more and more, I think there's a few other settings in here that he may have in place. Max roughing step down. Okay. We don't have minimum step downs or anything turned on. Beautiful. Oh, because you're doing a pocket strategy. That would explain also some of the stuff going on. So again, is you may actually be a little backwards in your thinking. So let's go max roughing 15 down. We'll have to fix that. But now you're seeing that the roughing is really starting to generate more and more. So let's go in. We're going to go ahead and give this the selection that you originally had, limiting our toolpath. As you can see, something as simple as your max step down is also something that could have been breaking tools. But what I'm doing now is I'm just going through, cleaning this up a little bit. We need a 030 possibly on this tool. Selected boundary once again, because we're just working down inside of more or less a groove now. So again, we don't need to do the entire pocket. We could just focus on that one little area. So how's that looking on your end? Give you a few seconds there, Will, to let us know in chat. Now that all that material is out of the way, right? Is regardless of what strategy you start to do in there, you're going to notice from this toolpath to this toolpath, there's not a huge amount of material actually really getting removed, as in plowing that tool in there to break stuff, right? So again, getting a little bit further, your scallop might have been a little bit better, but I still think at the end of the day, I would have went steep and shallow here. And if I drag this up, we should be able to see this. So again, we go ahead and simulate this tool path. I'm recommending going from a large tool down to a smaller tool as much as possible, right? So again, as you're seeing this tool path, a little quick here, let's get it slowed down. We're working top down also, which means we're never really plunging that tool down into our material. We're taking minimal cuts as much as we can. Again, even when you're starting to get over in this corner, we're just working downwards. We're blending everything nice, clean, and smooth. So usually the use case that I would use on a mold cavity is kind of like you have here, right? Big flat end mill to rough everything out, smaller flat end mill, smaller flat end mill, right? Then we go back. Now, again, this might be personal preference depending on who you are. You may want to finish, if you're going to go from a big end mill to another end mill, very simple to do so. Then go smaller, smaller, and smaller, right? So again, there's a lot of argument out there. I see more of you guys showing up in chat, but overall, usually I always want to work biggest to smallest and tend to stay with a bigger tool as much as you can. It's not always the use case. Sometimes you got to swap out one way or swap out the other way, right? So this is where, again, if we look at this, you're doing this with an 062 flat end mill. Now, I may want to get in there with your 062 finishing strategy, if I can, right after. But what would determine that on my side is, did I get enough material out of these corners to make a clean tool path, right? So again, I look at that pocket clearing, pretty heavy steps in there still. So I might make that choice to actually utilize a smaller tool to rough out before going into my bigger tool roughing, if that makes sense. I see some more questions jumping in. All right, so Travis, you ready for this? I know you were asking about the old 10 pockets with pit bulls. Yep, and then you want to flip the part over in the same parallel being held. Cool. All right, so Travis, first and foremost, I would have to ask you, is in your configuration, you're dealing with one pallet with 10, and then your second setup, is it the same number of 10, or is it more or less parts? I see some talk about a member of a group. Stuart, I see you out there. Awesome. Great to have you. Can adaptive with the ball nose? Yes, you can 100% do an adaptive clearing with a ball nose. Same number of parts. Awesome. So we'll go ahead and jump into that. So I still really need to do this. And I think now that Travis is bringing this up, it's a great time to remind me, is starting to get into the world of utilizing the ability to link toolpaths to one part and apply them into an assembly or like a tombstone kind of configuration. So with that being said, what I'm going to do is I'm going to shift gears here real quick. In the cavity, Stuart, yeah, real quick. So this is technically a pocket strategy. Let's switch over real quick to adaptive clearing if you wanted. I'm going to have to drag this up. Rust machining is going to haunt me now, guys. Here we go. Let's get back up to the top. So that is now a adaptive clearing strategy. And then the problem is going to be we have way too tight of area. So I'm going to have to get minimum radius turned up. But you can 100% rough out with a ball end mill. It's not really recommended at the end of the day, but you can. To say the least, you can definitely go in and do a toolpath strategy for roughing with a ball end mill. It could get you closer, yes, by all means. So the idea would be, Travis, as you're saying, yep. So if I was to start off, and I'm going to do this very generically because I'm going to need a couple of things for this to work, is first and foremost, I'm going to just generate a very simple part, right? So here we go. We have a rectangle. We have a hole. Let's just go ahead and throw a second rectangle in here. And what's going to happen is I am going to build this as if it's just a rudimentary shape, right? This is just a placeholder. Now, normally, if I save this, this would be your part, right? Now, in the case of this part, I can apply toolpaths to an individual item. So again, I'm just pet peeve of mine, get the sketch out of the way. We create our setup. Where you create your setup work offset does make a difference. So in this case, if I was building out some type of pallet system, I'd probably want a uniform location. Again, this is all built off what you guys are going to utilize in your shops. But from that, let's go ahead and face this off. Grab, well, where do we go? Local libraries now? Oh, that's right, because I just grabbed a bunch of stuff at one point and burned them. There we go. So they were facing it off. Let's just go ahead and throw a path around the outside. Again, let's go VF2 half inch flat. There we go. And then maybe we're going to do, you know, a real quick adaptive clearing in here, right? So as you guys can see, I've applied a couple of tool paths to this part. It's now started to change and modify and manipulate. Now, where this is going to look really, really funky is if I was to now go over and start my jig and fixture, right? So again, we're going to go ahead and draw this up on a second sheet. And I'm just going to make a very simple pocket for this. Extrude all of this. Repeat extrude. And as you guys can see, I now have the pocket for the part to sit in, right? So the idea is this is now my palette. And with that being my palette, I may have multiple different palettes for the multiple different setups. But if I was to build everything out properly, and I say properly here, because I screwed that one up already and I'm trying to cover up for it. The idea would be is you would now have your manufacturing, right? So with that, if I go in and I now start to insert my items, right? So we got our parts. There's my part. Here's my palette. Give it one sec here. Maybe. There we go. Part, palette, so forth and so on, right? So if I was to now do a joint, or if you guys didn't know, you can now do three-face alignment, which is sick. Let's just say it's going to sit there, right? These are all placeholders and these are all hypotheticals. Now, when I jump over to the manufacturer workspace, it's going to ask me to insert said manufacturer data. Now, this is what we're after at the end of the day, because now this setup is linked to the part, which includes all my tool paths, right? Now, this is where we can either start to pattern or multiply or build out more and more pockets. So a couple of tricks here is, as you guys saw, I extruded that pocket separate. Makes it easier if I just wanted to do a rectangle pattern of features. I can grab that feature. I can now set my axis and direction. A couple this way. Go ahead and do a couple that way. And as you can see, that the palette has gotten much crazier. So again, we go back to manufacture. We're going to bring through the latest design. Again, this is a pro tip for you guys out here. This is where you got things like your duplicate with joints. Very neat thing. I picked that first part, and just like that, I can go place these additionally, right? So this is something very quick, very fancy. You could have also patterned this, guys, by all means. But once we go to manufacture, again, we could insert the CAD data to all of those. Now, this is where you might have an argumentative thing. Because on one end of the spectrum, each one of these right now is its own work offset. They're all individually placed, but the toolpaths themselves are still linked together. So if I was to post these all out, the real problem is going to be is I'm going to have G54 times like a million. But one other side of that is if I go to operations, minimize tool changes, everything is pulling through as needed, right? So from that, as you can see, one way to do that would be to pattern out those components. Now, in my opinion, we could also go through, and this is where I need to build content on this and get a little deeper and crazier with this, because as you're noticing right now is I really don't have any control over moving any of the items that we've brought through. So I'm trying to get with Autodesk to see what their end goal is with this, with inserting manufacturer data. Or is it one of those things, do I need to know where that exact origin is, which doesn't make sense to me at the end of the day, right? So again, as you guys are seeing, is I can't apply fixtures, I can't do anything here once I go in to edit that setup because of how it's linked, right? So this would be one way to approach it. Now, if I was just doing something to make sure my toolpath can clear everything, this is a completely different scenario. Again, there's a lot of ways to do this, but the way that this is going to work best for you is when you get into setup 2. Again, I'm going to create a new setup here. We're going to go ahead and flip Z. Again, continuous rest machining is on. And then we're just going to go ahead and steal one item just so we have a toolpath to work off of, right? So as you're seeing now, we're facing off the backside of that part. We hit save. Everything's linked together. We got to go get the latest and greatest. This might be where, again, this is why I'm trying to show this to you guys, is this could be where now I need a new palette. I'm going to rinse and repeat and use the same palette here, but this is where you could position that second palette. Again, flip it over, whatever you got to do for your second setup to align your parts, right? So again, if I was to now, let's see here, let's just say we're going to do a joint from here over to here. And let's say we're going to rotate it. We're going to actually leave it there. I picked the wrong corner. That's on me. So let's cancel that. Again, perfect example. If you guys look, I don't have a corner to go off of here, but we could do now instead constrain component based on 3 faces. So if I wanted this face here, as you guys can see, it snapped over. I can then add additional. Again, it's going to look a little messy at first, but here to here. And then lastly, we want one more, which could be possibly the bottom to the top. So again, that was a 3-face alignment getting into that second setup. But when we make our way back over to the manufacturer workspace, again, we've brought through our secondary setups now. Again, depending on which one you have active, your continuous rest machining would come through and utilize and show you that stock model. Now, it's not the cleanest of workflows right now. I understand that. And that's why I'm really trying to get with Autodesk to understand what is the goal here. Is it nothing more than trying to put, your vise on a machine? Is it going to work for multiple parts spread out? Is it really only a setup 1, setup 2 palette system, right? But the fact that we're seeing this is about the best way I could tell you to do it. I personally, at the end of the day, when I work in palettes, especially utilizing 1 per, I simply would just go in and lay out each one, and then it would just be, again, a design modeled pattern. And then I wouldn't care about toolpathing each one because I could duplicate my toolpath. For those of you out there that don't know this, I'm going to go ahead and get back to setup 1 here. And what I'm going to do is I'm going to create a brand new setup based on, in this case, we go ahead and expand everything out. Here's my parts. And then here is my fixture. And if we go ahead and hit OK, as you can see now, my newest setup utilizes all of those locations and parts, right? So again, there's several different ways to go about this. I'm going to go ahead and just go ahead and face this off. New operation, 2D face. There's my face mill. And then I could do a component pattern instead. So again, new pattern, component pattern, pick your source. It went out and found everything automatically. I was just trying to see if you had an easier way. How would you separate the palette with like a configuration for op2, op3? So I would have done just basically the same thing I did here. So if you guys notice down here at the bottom, let's get these other setups out of the way. We go ahead and break the link and then delete them all. So again, you could always break that link and then now have full reign over changing everything. I am just going to rip these all out of here. And then with that, again, we did setup 1, getting into setup 2. Again, we go through, we pick setup 2. What is your models? Whatever they're going to be based on your, again, fixture, palette number 2 now. Again, I will have to define my Z-axis, of course, which is going to require being flipped. No stock. We're just going to go ahead and leave that a fixed size box for temporary reasons. But now you're getting into setup 2. Again, the real problem is, and this is something I've asked Autodesk a bunch about, is just when you're in here, This is where I think manufacturer models would be one of the best things ever. But the problem is without manufacturer models in play, it's just the manufacturer model won't look at stock from one setup to the other. And if any of you are wondering what manufacturer models are, is under setup, you could do what's called create manufacturer model. What that will then allow you to do in your setup is to select a manufacturer model. But when you select said manufacturer model, you cannot really machine that part with continuous stock. So it's kind of a double-edged sword with everything going on. And I'm a big fan of being curious about like, what is it that they're trying to do? Because I now need to reference a specific model. If I utilize the same part, what you're noticing now is I can't really pick that part. It's a little messy. And I'm hoping to see that they iron it out and make it quite well. So any other questions outside of that before I jump into a few other parts? Travis, again, I'm going to try to build some content. I got to get down and figure out, like, again, what was the idea behind it? Like, where are they trying to go with it? So you could 100%, it's an old way to do it. As Travis is asking right now, is I'm going to go back to the individual part. But as you're going to see here is if I was to simulate this, what you're going to notice is I'm left with a solid model. Now you can right click on screen, go to stock, and then save stock, right? So as you're going to see is I'm going to output this. Again, you could save it to a project in the cloud. This is a representation of the material. Now with that, we're going to give that a second here because it should be loading. I think. There we go. And we'll now see a stock STL. So again, going back to the side of manufacturing, let's get some of this stuff out of our way. I could now insert the stock if I had to, or I mean, presumably I should be able to go back to design, insert the stock here. We need to create a Fusion design here real quick, and then we'll insert that back in. Let that sit there and load. Didn't take too long. Usually goes pretty quick. We'll give it a few more minutes. It's scaled weird because it's going to be in metric, not inch. So when you insert it, that's going to be the biggest thing you're going to fight. So again, we're going to refresh here. We should have our stock now. Now I could drag and drop it in. So yeah, so this is the problem he's facing is when I bring that in, the scale is way off by all means, right? So you could put it back in the original file. Now, again, I'm just going to hit cancel here real quick and undo this. Because if we were still in manufacture, when you get down here to machine your second operation, again, I'm going to just go back to fixed size box. Actually, I think it was relative size box. Regenerate that tool path, simulate with machine, and then right click stock. I could now load, get this up a little bit higher for you guys. Stock, load model as stock, things like that. Now it's, again, a lot of different ways to do this. You can see I could load stock. As you're seeing right there, that is now the stock in the background hanging out. So if I was to machine anything now, it should presumably reflect what that stock was. Now, the real trick to this, again, as you're seeing, is you're manually having to force this whole save stock. Now, you can only output it as an STL. It's kind of a really ugly hack that they remedied by utilizing instead the actual from preceding setup continuous rest machining. My biggest complaint here, again, Autodesk, if you're watching this, is because it needs to look at the setup, all the setups need to reference the same model. When I use manufacturer model, I cannot reference the same models. It's just this crazy, wild goose chase of what is the right way to do it. And again, manufacturer models, I love. It works amazing in the mindset of utilizing it for nesting. I would personally like to see it more utilized here, which would be super value. Again, we're going from setup 1 into setup 2. It's not a setup 1 and done. Yeah, I mean, get the checkbook out. Ken, great to see you out there. Travis, I shouldn't say checkbook. We don't like taking checks over here, but you can go to our website and use a credit card all day long. So again, let's go ahead and shift gears here. We're going to go back over to one more part. Somebody did send this in. Now, they're not going to be on this meeting. I appreciate having them here. Ken, was it you that sent me this part? Let me go check my ticket system. I'm sure you guys aren't sending me a bunch of crap. All right, I don't see anything here. Of course, Stuart, I now see your email. So let's get this downloaded real quick. And let's take a glance through here a little bit more. All right, nothing too important. It was Ken. Ken, was it you? Are you the one that sent me this part? I can't see if you're responding. Yeah, it was Ken. All right, cool. So let me get another drink here real quick. So as you guys can see, Ken sent in this lovely housing of some sort. Looks like a valve, some type of shut-off valve housing. Now his question was, if I pull up his email, let me get back here. I'm gonna have to move some things around on my other monitor. So first off, Ken's working late tonight, so give him some props. Looking for the best finish pass on this part. So presumably I'm going to be under the assumption that Ken is talking about the outside of this part. Now, this kind of circles back to the same concept as we were just talking about when we were referencing Will's part over here for the fishing lure, is what is the best way to get down and finish out things. Now, as you're going to notice, this is a very small part, but if we shift gears to a very large part as well, we are going to be utilizing and working on the outside of this part. So first things first, for demonstration purposes, we're going to go through and make sure that everything checks out here. I know he's got a lot of toolpaths that have kind of been all over the place. And if you guys are wondering, he's adding a solid model for his stock to which he's mounting. And then I believe you're going to go ahead and mount this with, I believe, pull studs and stuff. So he's got his first operation here. Again, his stock fixed size box, pretty straightforward. I don't know about those millimeter units, but we can continue down. Now, I've seen a lot of people do this at the end of the day, and I'm curious why you guys like to protect your stuff. But what I'm going to do is I'm going to check his second setup. His stock for his second setup, this is where, Ken, I'm going to pick on you here, is if you have a solid model for stock, you should probably continue using that same model. Now, the reason why you don't want to use from preceding setup is because although those features are milled, you've actually made your own stock. So this is where I would go from solid, go into his models list here, pick his stock, and then let's make sure the body that we're manufacturing is that housing. And then let's unprotect everything and make sure that we completely ruin everybody's day. There we go. And we're going to regenerate. So again, looks like he's decking off the ends here. Oh man, what do you got going on? You're in the part over there, aren't you? Or is that just my vision? Getting old. My eyes are going. There we go. So he has actually roughed in both ends. He's now doing the face. Okay, cool. And for those of you wondering, the reason why I'm doing this is if you notice the stock model is now loading in the background, which is something that is going to be very valuable when we start to work the other way. Now, me personally, this might just be me, is I probably wouldn't have wasted my time with any of this stuff here if I didn't have to. And that's just me. It's just a lot of machining time for something that later on we're going to rough out anyways when we look the opposite direction at this part. Now, as you're seeing, he is roughing out everything inside. Few adjustments I might make is you use this big, lovely tool 46 up here. And then down here, you switch to tool 15. This is where I would possibly use tool 46 instead. Another thing I would do if this was me is if you guys notice, this is taking forever right now to calculate. It's because he's using adaptive clearing with what looks to be a high feed end mill, right? So this is where I would personally, I wouldn't have used adaptive clearing. I would have used pocket clearing. And the reason for that is because you don't have flute length. So let's just use the full width of the tool to be able to rough everything out. So again, we go pocket clearing. use like a 90% step over. So again, we have a max step down versus step over. And we're going to reorder this real quick up to the top. And let's trash this guy. So as you're going to see now, very quick pocket clearing, roughs out all that area. We could feed the crap out of that end mill. So as you're seeing, we get further and further down. We should start to see more stock models come through. He is now starting to do some things on the outside of the part. Again, this is just my personal opinion as we work through here. Okay, so you cut the corners off of it. Trying to figure out what you got going on with 46. Okay. And then you do this. Okay. I think we're good for the most part. Not necessarily the way I would have done this, guys. Don't judge me. Don't judge him, of course. But as you're seeing, he's slowly working his way through here, which is getting better and better. Now, this is a scallop toolpath for those of you wondering. This is a lot of toolpath here. Now, depending on what he was going for, this is where I would possibly, instead of scallop, again, I would have gone for something like steep and shallow. Now, the reason why I would have went steep and shallow is because, again, we could have silhouetted this entire part. Looks like he's not trying to touch certain areas. That's fine. Go additional offset 0. I don't know the translation between millimeters and inch, but I think we're going to get a lot of what I want. So again, you guys are going to see now, if I bring this back up, there we go, is again, with that steep and shallow strategy, I think he's avoiding surfaces in here for you guys if you needed to understand. Now I'm going to show you some tricks here because this is very valuable, but the steep and shallow strategy, I don't know how well, can you guys see? Is again, we have a different step down so we can actually consistently step down the same in Z and then get to certain areas and actually transition back to that scallop. What you'll really notice though at the end of the day is his 8-hour cycle time for one area versus a 5-hour cycle time for specific areas. Now, what I want to show you is a lot of people haven't realized yet that you do have the ability to group things together. So that's what you're seeing here is like where to go, where not to go. But you also have that ability at the end of the day, instead of doing avoid surfaces, well, let's get a couple of these out of here. And this is why I like steep and shallow, because I'm actually going to trash that entire group. So there's our model for manufacturing. Steep and shallow has the ability to exclude flat areas. So we're going to get that kicked on here real quick. Give her a few seconds to calculate. And then we're going to actually use gouge checking. So this would be one of those situations that if you're going to bore these for bearings or seals or gaskets, I might actually go in and instead of utilizing the, where was it here? A straight avoid surface, you could actually do gouge surface or things of that nature, right? So again, we could say gouge surface, wherever those are going to sit. Again, with that, we have that to utilize for our toolpath, or again, using avoid in a smaller group setting. So if you guys have ever seen our training at the end of the day, we do like to go out and justify in our training that with that gouge surface, you're noticing that we're now avoiding those surfaces. But we always tell people, start at the top of this list, work your way down, only do as much as you really need to do. Again, we don't have contact point boundary turned on. That would be a big one that's going to help a lot with avoiding those gouged areas, things like that. So again, there's a avoid, there's a touch, and then there's a gouge as well. So not the cleanest of tool paths at the moment, but this is just something I would walk through on a part like this. Again, maybe instead of using gouge, we go ahead and utilize a avoid. Again, we could go avoid here, avoid there. Let's avoid this little guy here. But notice how I'm utilizing the fact that the whole model, I'm no longer in a very specific selected boundary. I did things like avoid flat areas to stop toolpaths at certain times, things of that nature. So again, we'll give this a few more seconds, but then we're going to get to the back side of the part. Again, as you're noticing here, we do have that avoid touch surface on. We could change boundaries even more, but this is why I like the steep and shallow strategy. So let's get down a little further. Now, the importance of everything I've done so far is just so that when we get down here to the bottom of this part, we can actually get the stock model through so then we can look at the surfaces themselves. Now, one thing I did notice already on this is make sure when you're doing continuous rest machining that you check that lovely little continuous rest machining box, because that is going to be very important as the tool paths calculate down and through. Now, finishing wise on this part, I think I would still look at something like steep and shallow or geodesic, depending on what you're going for. But my question would be, is there any like aesthetic requirement to this part, or is it nothing more than machine it out, right? Because when I'm doing machining, I'm a big fan of going through. We're going to have to wait for this. It's going to take some time. Again, this is the sad side of adaptive clearing, where if we would go through and do pocket clearing, and let's get rid of adaptive clearing. And now you can see pocket clearing just calculates extremely fast. Again, going a little bit further, I'm going to convert these all over so that we can get somewhere in a short period of time, pocket clearing back up to the top. But I don't want to bore you guys to death with it. So I am going to go through, and what I would have done is just pocket cleared the shit out of everything. Done from proceeding. Beautiful. So we'll give that a second to calculate. There we go. Ken, you owe me some beers. Possibly just saw my phone vibrate as if it was, nope, somebody else that's hopefully wanting to give me money at the end of the day. But yeah, so the pocket clearing strategy when you're using an end mill, I always explain it like this. So we're going to do this why this calculates. But as most people know, it's a pocket clearing strategy is not necessarily for pockets. It's not. It really is not meant for pocket versus adaptive. And this is my biggest argument about this is if I go into adaptive clearing, in 3D, it's always defined by a boundary, and it's always based on inside that boundary on center or start outside. That's a pocket by definition, right? The same thing would happen is if I went 2D adaptive clearing, what's it asking me for? It's asking me for a pocket, as funny as it is, right? So that is where at the end of the day is even though it is called pocket clearing, it's still utilized to do a lot of my machining that I need. Now I am realizing here, I duplicated some toolpaths. Those toolpaths were set to not go from stock top. Model bottom. Let's go ahead and calculate that one more time. We're also going to bump up the step down here just to get a much faster toolpath. I am taking questions there, Chris. What kind of questions you got? As soon as Ken buys me beers, I'll answer that question and leave his part alone. No, I'm just kidding. So again, we'll give that a few moments to calculate. I do like what you're doing here. You are roughing in one side, then jumping to the other. I think one thing I didn't do on my pocket clearing was, oh, nope, we do have from proceeding. Beautiful. I feel like I saw a toolpath trimming somewhere in there. Maybe I'm crazy. But outside of that, let's give a few more seconds for this. But basically at this point, this is where I would start going in. And now I'm going to be a big fan of doing everything flat and then everything that's not. So let's see what we have here. 20 millimeter flat end mill. Beautiful. So now we're going to go out and recognize anywhere flat. And so you guys can see that's that roughing strategy. F7 to turn off that actual tool path. Again, I don't want to say it for what it's worth. You might have to give me a job application because the amount of time I'm starting to shave off this thing justifies my salary. But again, what you guys are seeing is we just did that adaptive clearing, not adaptive, pocket clearing with a shell mill. And then from that, we're now starting to go through and recognize all of our flat areas, right? So anytime there's a flat area, I like to see if I can pick that up automatically. Again, the whole goal is to get down to the finished surfaces and machine as much as I can before getting into surfacing. Now, flat does have the ability to utilize 5-axis. Now, from that, you may want to limit your tilt angle. And this is why I was kind of pointing out earlier, if you are doing a lot of facing cycles, which you were up above, right, to hit all 4 sides of this part. So you were doing these guys on the end, but if I use 5-axis flat, again, let's just go ahead and up our tolerance real quick, get a little faster toolpath, is I'm now going to go through and recognize everything out to a tilt of 90. So it's going to pick up on my flanges, It's going to pick up on all of my lugs. Again, what you're seeing here is a crazy automation inside of Fusion to build a better and better tool path and to make machining much easier. Now, I know I did a lot to get to this location location to this point, but this is where we could now start to do a lot of our other machining, right? Now, personal opinion, there might be some arguments out there, but what I'm going to do is, what do you got for tools in here? Do you got a ball end mill, 16 millimeter? So let's start with the 16 millimeter, unless you got something bigger. I'm not really seeing anything here. Now, what I would do is I would do a pre-finish. And what that pre-finish is going to consist of, stock to leave. We are going to keep the tolerance kind of high. Again, this is just so that we get a fast tool path. I'm also going to do a much larger step down and step over than I normally would do. So again, this might be more like a 4 millimeter. Well, how big's our tool? 16. So we probably want about a 2 millimeter step down, maybe a 1 millimeter step over. And we're just going to let this thing go through, knock all of our cusps off, all of our steps, all of our other problems that we may have. So again, the whole goal right now is just to simply get everything cleaned up. And as you guys saw me do before, we got flat areas I want to avoid. Again, we could go through rest machining to avoid certain areas. I'm a little confused on stock to leave. Give me a minute. I have to switch back to millimeters here. So stock to leave a 0.1. We're going to ignore stock less than 0.4. Turn on flat areas. And let's just double check this here real quick. So again, nothing more than trying to get a good surface finish could be dependent on being able to knock off those cusps quick, fast, and in a hurry. So again, we're going to give this a few more seconds to calculate. Now, I did see some people asking about geodesic. We'll go ahead and take a look at that. Now, the reason why we may not want to use geodesic might be shocking to some of you, but as you're seeing now, that rest machining is avoiding the lugs that we've already done flat. We also have exclude flat, things of that nature. But one thing I want you guys to look at is the minimum amount of stuff I'm putting into these tool paths, right? I have gotten things down to a streamlined process where I am not adding a bunch of extra things to the tool paths, right? So for example here is we're machining the outside of my part. Now I could go do avoid touch surfaces, but the real problem possibly is actually dependent on the fact that I only want to work off of a silhouette. And I only want my tool center of the silhouette inwards. And then I want something like contact point boundary. And what that is going to do is shift my tool out to radius of engagement versus center line. But notice how I'm still up here, right? I'm not down here trying to do a bunch of stuff. I'm just simply working from the top down in that menu. You were trying to do it with the 16 millimeter ball. Okay, we're gonna, again, I'm a big fan. Get it in 3 before we go 5, right? Because if we wanted to right now, we could still stick with steep and shallow. And there's going to be a reason for that. And it doesn't really matter what 3D surfacing tool path you guys pick. You will start to notice when we talk 5-axis, there is different options for different tool paths. This is a 5-axis scallop. We lack lead and lean. Why is lead and lean so important? Well, you don't want to cut on the center of the tool. So this is where, again, steep and shallow, beautiful tool path. This is where we start to make those decisions on how we really do this at the end of the day. Now, again, being on a 3-axis or a 5-axis, 5-axis is nice. More axes mean more cycle time, right? But as you guys are seeing, again, I made a boundary change. I'm no longer touching the flanges in areas of that such. We're excluding flat areas. Yes, we got a little bit more that we need to go through, but this is mainly meant to be a pre-finished strategy. Now, I'm going to duplicate this. And for the next thing, this is now going to be my finishing. Again, we go through and we say no stock to leave. Again, for calculation times primarily, guys, I'm going to go ahead and set this to 3 and 2. And then with that, let's just go ahead and give that tolerance just a little bit more and see what we get. So again, now we're moving into finishing. Normally in finishing, I'm going to make a smaller step over, a smaller step down. And the whole goal behind that is so that the tool is now taking a smaller bite, right? So again, I machined all the bumps out of it, and you can see that. So if we go ahead and hit F7, if we looked at this from the side, notice how a lot of these surfaces are still very curved. But if I go one step above that, when we did our flats, right? So that's only the flat areas are now pretty, but we're getting the staircase effect. And this is what I want to get rid of, because if I was to try to up mill or down mill across this, as I hit these, it's going to just be more and more effort on the tool, more and more deflection, more and more surface finish problems. So again, I'm going to go down. We now machined our pre-finish, which means if we zoomed in here far enough, we're seeing our scallop heights. This is the edge of my part. There's still 20 if it was an inch left everywhere. And now I get into my pre-finish, into my finish. So again, I'm going to go ahead and hit F7 here. Now, we still have rest machining turned on. So keep that in mind. Rest machining right now is technically screwing me at the end of the day because we are ignoring stock less than what our, or actually we're ignoring stock greater than our stock to actual leave. So again, we could go through, can't remember what I set it to. Did I do 0.2? You know what? When in doubt, go back and check it out, right? So again, initially we did stock to leave of 0.1. I might take that now. Again, I want to ignore stock less than 0.09. And we should get another toolpath. But this is, again, what you guys are seeing me start to work down through. The next goal would be is how do I do this? I can now transition into multi-axis. From there, I can now do lead and lean. Again, the value of lead and lean is I can force a tool to be leaned over or leaded, meaning lean forward versus left and right. And then I can lean backwards as well, but I can stay off the tip of the tool, right? So as you're going to see is if I was to now say lean and lean, I could lean the tool at 20 degrees. I could also set tool axis limits. Again, there's a lot of things that you could do with this. And what this is going to do is basically say, I want to go no further than 90 degrees, so forth and so on. So again, you can see my tool path started to show up there. Now I'm turning on multi-axis, and now I'm going to pivot a little bit more because this is where I might go in and start to do things like the corner strategy. Now, if you notice, the corner strategy here is really well built out so that we can go through and machine specifically features like this down here, up this corner here. Again, another great toolpath that is going to make machining much easier at the end of the day. So now I always mess this up, but I want to make you guys aware of this, is I said 20 degrees, which 20 degrees in this case is actually, let me get back to the right tab here. It's 20 degrees from not vertical, if that makes sense. So if you look down at the bottom, oh, my fat head's in the way. Can I get out of the way here? So if you look on my right, I guess your left, you guys will notice that that very first thing is if you're at 0, it is perpendicular to the surface. If we go to 88, which is the one on my other side, there we go. Can I get my chair out of the way? We're going to be the opposite direction, right? So I did get it correct. So now if we were to machine this, we're going to go ahead and simulate. And as you can see, we're getting one of my favorite errors that I always see inside the software. Pablo, great to see you out there, buddy. But that issue that we're getting right there is upon post-processing something, somebody has turned on A-axis rotary for some reason. I don't know who, probably me. But let's get this posted. Again, we're going to get a fail. That's fine. Rewind, pretty typical stuff. We can go ahead and now take care of my second favorite error, which is at the machine level. And that machine level, we're going to go in, give it a sec here, multi-axis, retract and reconfigure. And the reason why that's happening is because either your kinematics are going to be limited. In this case, we don't have limited kinematics. We do on the B axis. So at some point, the machine has to figure out how to unwind and rewind back up. I'm only having the best of problems on this part, if you guys can't tell. But again, let's simulate finally, right? As you're going to see now, maybe, is that we can simulate this toolpath in real time and see what's going to happen. Again, we'll give this a few more minutes. We're actually an hour and 20 minutes into this, which is wild. We've been going hard. A lot of fun, challenging parts. It's why we do this at the end of the day. I'm going to give this a moment to load because I have a feeling it's really trying to load all the stock models in the background, which means if you guys have questions at any time, feel free to ask them in the comments down below. Feel free to send us an email. Feel free that if you've learned something new that you find value in and want to give something more like beers and steaks, we're always open to it at the end of the day. You can also purchase your Autodesk software through us here or move your Autodesk software over if you guys are in, I used to say North America, but apparently I can't sell in Canada. But if you still want to give back to our channel, we do have a partner in Canada that we can renew your software through as well. So at this point, my Fusion is locked up. We're going to wait. We're going to give it a few seconds because I think it wants to simulate, or we're going to get one of my favorite things, which is the good old-fashioned Fusion window. In the meantime, how's everybody's week been? How you guys been? I know it's been 2 weeks since we've done this, right? I might just have to force this guy, restart it. Computer's loaded down. Yeah, I mean, if anybody's legendary at completely making the computer not happy, it's me. Speaking of the fact, actually, Travis, you point out a really good thing. Hey guys, so I'm gonna go ahead and put this out there. A lot of people have been asking me about computers lately, and I just want to show you something here. So one of my customers reached out to me. They were looking at purchasing something of this caliber, and I'm going to tell you, do not go out and spend $3,000 on something of this level for doing Fusion 360 CAM and CAD. What you're paying for on a computer like this is more or less the graphics card, as well as this does come with 32 gigs of RAM, actually 64 if I remember. I could pull the specifications down here. So 64 gigs of RAM, and you're getting, you know, the top of the line Ultra 9, which replaced the i9 if you guys didn't know. But overall, for the almost under half, is you could go to Dell. Now, this is the Ultra 7, which is like an i7. It is going to handle Fusion extremely well. I have this processor in my desktop that I use. I don't use my desktop anymore. I use my laptop. But you could get an Ultra 7. The 5060 will have no problem for Fusion 360. And for literally $1,200, turn around. For another $200, you can go out and you can pick up a RAM kit to get you to 64. So again, for another $210, you guys can very much upgrade a desktop that cost under half, actually almost a third the cost. And again, I'm just telling you guys this is you don't need necessarily the Ultra 9. I'm going to be honest with you. To me, it's not worth the jump in price here. If you build your own machine, yes, go Ultra 9, right? But overall, the Ultra 7 is kicking ass at the end of the day. I'm going to jump back to Fusion here. I think she's locked up. I'm going to go ahead and shut her down here. So we're going to go ahead and close the program. I think I angered the system. I noticed that the stock model didn't come through there as well. And we'll give this a few moments to load back up. Need to get with me about a laptop. Yeah, I mean, at the end of the day, guys, I do still have my old laptop and I have my desktop I think I'm going to get rid of because I jumped over to a laptop. And I honestly, with as much as I travel and this content as you guys see me make all the time, it is much better to me to be on a single computer that is portable with everything and anything. So again, it looks like we got everything here. It looks like we were at the last save point was rest machining. Let's go ahead and just, for the sake of this part, 5-axis, lean, 20 degrees. We want lean, not lead. And let it recalculate here. She's ultra and mega, the computer. Again, at the end of the day, just so you guys know, a lot of people always ask me this question, is always go for a high core or a high clock processor. That is where you should spend your money. Do you need 64 gigs? No, you could get 32, save a few more dollars. Don't go 16, always go 32. So let's see here. If we get lucky, I'm going to do this. We're going to do a normal simulate, and we're going to see if it locks up. You got an orbital and thinks it should run better than it does. Okay, so we got normal simulation. Again, I just want to show you guys an example here. As you're seeing, that toolpath is actually doing the scallop. It's going to look weird because we are calculating the toolpath from the tip. So again, you're going to see a lot of weird jagged lines that happen. But notice when we're jumping around, we're not cutting on the very tip of the tool, right? So if I get stock turned off here, we are engaging at the 20-degree mark. And that is where you're going to get a much better surface finish by all means. Now, the strategy that you use to do something like this, again, I'm using steep and shallow. I'm doing full 5-axis tilting. I will tell you, no matter what you do, and it's not just a Haas thing, there's a lot of machines out there with this problem. When you start tilting more axes, your cycle time is going to go up dramatically fast. There's also a lot of things on this part that you may approach without utilizing steep and shallow or full 5-axis. And what that could be is if you were to do something as simple as parallel, you could very easily parallel across this part. Again, silhouette, you guys have seen me do this, back and forth, what our step over is going to be, whatever you end up calculating out. But this could actually run a lot of times, a lot of what you need. So again, we're going down the part versus over it. I could do steep and shallow and use parallel. I'm going to go ahead and set a pass direction here. And as you'll see, is we're now running along the part. I'm going to up my step over for you guys, just so that we could see this a lot better. Again, you're noticing that we're going back and forth, right? So this could look really good on a lot of these housing areas, wasting our time once again on the flat areas. This might be where you start to use boundaries. Again, we could do a selected boundary. I only want to work in certain areas. You guys kind of see how this becomes a real rinse and repeat kind of scenario. Again, is I'm just going to go up and over this one lug. We actually might stay here. Again, up, over, back, down, and around. Well, let's just go ahead and set that for there. Oh, we went the wrong way, but I think you guys are starting to see the possibilities, right? So get the toolpath and the boundary you want. If you got the machining extension, feel free to go through, trim toolpath. Let's just say no to this whole area here. Keep the tool outside of that. Again, as you're seeing, as I'm very quickly limiting where that toolpath goes, we could, of course, trim this more. Again, there is no ability to avoid flat areas here, but you could do slope. Again, I don't know, I think it's going to be like 0.1 to 90. Now I'm avoiding my flats automatically. Again, until you really need it, there's no reason to get down to the area of using avoid machine areas, right? So again, contact point boundary, because I want a waterfall all the way down the outside of my part. Now is where I could go through and up the ante even more using avoid touch surfaces. Again, these are neat tricks that I've learned over the years, guys. Again, maybe we only go all the way out to 89.9 degrees. As you're going to notice, I'm no longer going to touch anywhere vertical. So again, this whole outside wall is vertical. We still need to waterfall down because of the radius of our cutter, but we can achieve quite a few things. Now, a few things I will also point out here is there is some luxury to the fact that when you think about your model, you could actually say avoid the entire model and then add in only surfaces to machine. Again, as what you're going to see me do here is just go through and pick these middle surfaces. So this is the outside the box thinking that if you were to buy custom training with us at jitcadcam, we like to teach people the neat tricks, methods, and ways around, as some of you probably just got your socks blown off at how I reversed the system. So instead I said avoid the whole model, but only machine those surfaces. Let me know, guys. Throw it up in chat. Did you guys just learn something new? I'll give you a few seconds here. But again, as you're seeing, this is, once again, a few of the problems are because of slope. We're avoiding this very top area of my part. But I did a lot of things in that toolpath that I could start to undo. Let's get rid of slope. Again, that's a parallel toolpath. For those of you that missed it, I reversed my system. So my model right now is actually a void, but the grouping I want to machine is now the actual action, which is fun because, again, you can now start to do your radial and axial stay away zones, 0.1, 0.1. We should now be staying away from a lot of these lugs. The lugs are now where I would go through. Again, we have the corner strategy. We have the pencil strategy. So really, depending on how pretty you want to get with this, this is why you have certain tool paths, right? So now we do pencil. I could do 5-axis pencil, kind of a waste of time, because I would tool orientate to this lug. And then that lug is my selected boundary, so forth and so on, right? So again, I have full reign over being able to go through. Now this isn't going to work because this tool is massive. But if I swap out to a much smaller ball end mill, if there's one in here, let's see what we got. 6mm ball. Do you have anything smaller? I think that 6mm still going to be, oh, she's going to be close. Yep, we're just starting to see that tool path. So let's just, for the sake of this video, we'd either go smaller or make our boundary a little bit bigger. And as you can see, I just did a pencil tool path around that lug, right? So there's no real easy way to achieve a lot of this, but there is a lot of tips and tricks, as you guys are seeing here, is now I've just used pencil to clean up around that area. Again, there's still a little scallop there. And the reason why that scallop is there is because we used a large ball end mill. We're avoiding surfaces, tons and tons and tons of things. So as you're seeing, this is where all the fun comes from, right? So again, you could simply, instead of doing pencil toolpath, actually, I'm going to duplicate that. Once I get one of them, becomes pretty easy to go get the others. Again, Z over here now. Boundary changed to this guy. And now we're doing pencil there as well, right? So again, if we were to do something with the corner strategy, I love the corner strategy because this is one of those tool paths that has a different way to look at your geometry, right? So we're very used to arrest machining based on what we've done up until this point. But this is the very first time where we're going to rest machine from a tool. What you're noticing here is I'm doing 3D tool paths, but I'm referencing a tool. And then I can actually do things like oversize the tool, increase detection limits, anything and everything from there. But this is, again, this is probably one of my favorite things about Fusion is there's no right or wrong. Again, the corner tool path is basically a really fancy way to do steep and shallow. But instead of utilizing things like your contour, still going to do contour, it's still going to do a scallop or a blend strategy. Again, this is where you have that ability to adjust that. But what's going to happen is it's going to allow it to run along or across, right? Again, up milling, down milling. All of these things are fully controllable at the end of the day. So again, just out of the box, we go ahead and hit OK. I failed to up my, we go back here real quick. We're going to go ahead and up that tolerance so we get a fast tool path. Again, for a lot of you out there, if you haven't noticed on some of these tool paths, they look pretty hideous because I'm turning my tolerance up to get fast results. That's all. So again, as we're going to see here is step over should be greater than tolerance. That's on me. I failed to do one thing nicely. 0.1. Step over 0.3. Step over. Okay, there we go. Should be able to make it happy. Outside of that, how's everybody else doing? Ken, great to hear it. He says, come tomorrow. Awesome. Glad to see how you go about it. Again, I know there's a lot of weird things when we start talking about multiple things on one palette, or as I would say, multiple parts from one work offset that would be a huge improvement inside of Fusion at the end of the day. Now she's mad. She's working. There we go. So again, due to that corner strategy, as you guys are noticing, we're switching from what is actually the blend strategy into contour. But now I'm going around and I'm recognizing all those areas on my part, right? Again, this is the fun of having things like the machining extension because I could say, you know what? I'm going to pencil these 3 lugs. Well, let's go ahead and snip that stuff out of the way. And you can get really close in here, which is amazing at the end of the day. There we go. Let's pull her out there. Stay outside of that area. Boom. So again, there's our blend strategy. Or not blend, that is our corner strategy. So again, we're getting up and over these humps. Some of these areas unrealistic to get into. As you guys saw me just do there, I did do the trim. Maybe I go ahead and I start to add in, avoid certain surfaces. I could also use slope again, as you guys have seen. It's just a rinse and repeat no matter what toolpath I kind of go to, right? So again, I don't want to do these lugs. This actually leads me into a really cool thing we could do. Is we could actually group things also, making selections easier, stuff of that nature. So what do you guys think? I see a lot of you guys out there. I know we had one more part, didn't we? We got to get another part uploaded here. Free Support Friday. Here we go. Episode 34. I feel like we've been doing this forever. Don't you guys think? I also fixed my camera. Had to update software. Don't we all love updates as Fusion customers? So Ken, you let me know how's it going and what do you think? If that's going to work out for you, I am going to, actually I could close that. Need to pop this back out on the other side. And let me see here. Stuart, you sent in this part. How to rotate and face this part, i.e., drop down, apply compensation, and revolve left end. Maybe I'm not reading this right. My brain is not working. Spiral down in Z as it rotates. Okay, so you want to utilize the end mill to more or less surface in a spiral motion downwards, if I'm collecting that data correctly. No more updates. Yeah, I mean, I don't know why people are still hanging out on Windows 10. It's kind of shocking to me. My rule is when Windows comes out is like after a year, I jump to the latest and greatest so that I don't have to deal with what a lot of you are going to go through. But I can give you a pro tip. For those of you out there jumping from 10 to 11, if you notice my toolbar basically looks the same, is again, you could go to your taskbar settings at the end of the day and taskbar behavior. And then you can come down here and you could say taskbar alignment to the left. So again, let's get back to this part. So Stuart wants to know about actually rotating A axis here in this case, but bringing the end mill down and just spiraling around the outside of this part. So what I'm going to do is I'm going to go for multi-axis and we're going to do a rotary contour. Now, I'm wrong. Not rotary contour. We are going to go for rotary parallel. And the reason for that, as you guys know, we're going to go ahead and hit the OK button because, one, we need blue lines before we figure out what's wrong with our blue lines. But you'll notice right now is everything is running down towards the end of our part, right? So we can fix that. Let's go ahead and go to our geometry. As you're going to notice, one, we have the wrong axis selection, it looks like. So let's go ahead and change this to setup X and recalculate. And now you're noticing my toolpath runs around the outside of the part. However, we lost the fact for it to actually come down this front face here. So this is where, again, I can walk through my steps. I can evaluate my blue lines. Again, jumping a little bit further, we're working from stock front to model back. Well, in this case, as you can see, we're actually backwards, but we're not too bad because if I just grab and pull out back, you can now see that toolpath is still not dipping down on the outside here. However, that could be for a lot of reasons. Let's go ahead and take a look here. So again, we have our model front, model back. We may need to do some lying at some point to this particular toolpath. But as you guys are seeing, everything is looking good. Stock OD looks like we're good there. Again, we do have a step over. We are doing a spiral motion. Again, this is where we may need to adjust our toolpath. So again, let's do a few more things here. And what we might have to do is there's no pretty way to do this at the end of the day, but let's just see if I can't do a very simple offset this face. And then we are going to extend this face. I would like to see if we could at least get a toolpath down that way, if that makes sense. So again, we're going to go back to manufacture. We're going to add an additional model, which is that little skeleton skin that we just made. So as you're seeing, we are wrapping around now, but we're not wrapping up and down this surface here with constant step downs, or basically it's going to be a live fourth axis motion, but we're not getting a ton of extra distance here on our part. So this is a couple of things. One, our actual step overs could be massively smaller. See what that gives us. Going to take a few more seconds now because we did give it a lot more to work with. So the tool is plunging. I get that you want to go outside in. Don't worry. We'll get to that point here at some point. And for the sake of this, the second part I was going to do to this is we're going to limit where we're working. It's a lot less toolpath calculation. And as you guys know, we'll get our tolerance turned up. Hopefully we'll get a little better tool. So as you're seeing, no matter what we do, it's not going to Z-step up and down when it's trying to do this, right? And that is the dilemma that we're basically working with in Stuart's case. However, there used to be an option. Now I could go to another toolpath as well, which I'm thinking of a few other things, is instead of using rotary pocket, we might be able to get away with our rotary contour. And the reason why I say that is because rotary contour does have automatic step downs and things of that nature to work with. So again, if we go ahead and do setup X, let's get a toolpath. As you're noticing, we're going around the outside of the part. We're in the same battle as before. Again, we have our front, we have our back. Let's pull our back out. Let's move our front closer to our actual working area. Give her a few seconds here. Now you're noticing we are spiraling around the outside of our part. So again, rotary contour in this case, Stuart, might be the better fit for what you have going on. Go ahead and get that actual contour out of the way. And just like that, we are spiraling farther and farther inwards. Now I need to limit this even further. And if you guys didn't know, this is where I could actually do some things like I want to use a selected edge. And now I want that selected edge. And if I type tool underscore diameter, divide by 2, give her a second here. I've now shifted my boundaries, right? So again, as I'm now doing some math here, and what we don't want is we don't want to start in front of or behind these locations. So we might have to do some adjustment as well. So again, a selection here. And if you guys want to see this a little bit better, I'm going to go ahead and click these 3 little dots, edit expression. What I'm doing is I'm actually using a parameter, tool diameter, which is the current operation diameter times 2. And in this case, times -2, because I would like to go the opposite direction. Is that a 6 millimeter tool? Me. It's me, guys. It's always me. So as you guys are seeing is I'm actually doing my math wrong. So we don't want to go divided by 2, correct. We don't want to times 2. Did I do times 2 here? I did. Divide by 2 here. Maybe. Divide by 2. There we go. Divide by 2. Divide by -2. No, invalid, because we need, oh, what's it want? It's going to want an increment of measure. Or it wants me to spell stuff right. Guys, there's a reason I'm a machinist and not an English teacher. Oh, we did that wrong. I'm going to have to fix that. Again, what I'm really trying to do, in case you guys are really wondering, is I'm trying to get this guy set so that it's working within a certain window. There we go. I feel like that's almost right. We got to get right there eventually, right? So there that is. And give her a few seconds. Yep, so we're going to have to bump it just a little bit more. Again, looking at that side view. This guy out a little bit. This guy in a little bit. We might also be able to stop it right at. But what I'm really going for is, as you guys are going to start to see on the end of this part, is we're getting that spiral effect, right? So if I was to run something like this, and if we say simulate with machine, might have to do some adjustments here, but what you're noticing is we're rotating around because we don't have machine simulation. But let's get these corners machined real quick. Yeah, it's going to keep stepping down. Let's just fix it. I always try to hack stuff up for you guys to make it easy, and it never works out that way. It's always a problem. 0. Still wants to wrap around. So funny that it does that. One more. Boom, there. I'm going to anger the system today. All right, that's fine. -4. Actually, it'd be minus. Any other questions outside of that? I know some of you guys always have questions. As you're watching me fail pretty miserable at right now is trying to get this guy not to machine the top edge. Now, I could put a boundary in here, which might be quite handy. But really, I just don't want to be touching this top area. And for some reason, she just does not want to respect what I'm trying to tell it to do. Let's do this. Oh, duh. Again, still on me. Now it's still on me because I'm positive, not negative. And every once in a while, you guys get me with some good ones. Yeah, it's still, we'll have to do a little bit more with that. But the idea is that at some point, you're going to get down and start spiraling inwards. And that's what I'm trying to get after here with this toolpath. Just getting what is the number that it wants and not touch that upper surface, right? Just, it's fighting me. Fighting me more and more and more. It wants a beer. Fuck, I want a beer after dealing with this stress. See, now it doesn't want to do anything because it's the same numbers. So, I mean, presumably I would tell you guys at the end of the day, there's no actual good way to do what you're trying to do with this. It's just the nature of the beast. Now, something I can think about, and this is going to be ugly. I already know it's going to be ugly. I've done this a lot. So we're going to go back to design. We are going to delete that extension that I did. Let's get the, let's just go for it. I have an idea and I think I know what's going to work. So this is the surface that I did pull from. Now what I'm going to do is I'm actually going to split that surface utilizing one of my planes. And the reason for that is now if I go back to manufacture, is if I was to do a traditional 2D contour, but do a wrap, as you're noticing is I can define what I want to wrap around, but then I can also define the contour itself. Now, the real trick here is you can't by default do 360 degrees inside of Fusion with a wrap. So what you're going to see here is I'm now wrapping around. I'm on the wrong side of this. Again, I need to go in, flip that chain so that I'm on the outside of my part like that. And then we're going to get there. I promise you guys, we're going to get there. Because the idea would be is without lead and leans, I could use ramp. What ramp is going to allow me to do is to spiral around that part, right? But I got to do it better than this, which I'm thinking of a couple of ways that is going to work. So I'm going to actually go back to design, not use the surfaces I've created, but I'm just going to drop a sketch on the end of my part. Now, the trick here is going to be is to create a arc based on center point. And you'll see why. Center, 1, 2, because I've now created an arc that's going to be less than 360 degrees around. So I have a start and an end point now. So again, I go back to manufacture. It's going to ask me wrapping my tool path. What do I want to wrap around? Again, whatever that face is going to be. My contour now this time is going to be that line. And you'll notice a giant mess, as you can see. Well, let's go back through this one more time. Should be able to unwrap geometry. And now I'm spiraling around that part back and forth. But it gets better than that, because if you were to go in and utilize things like tangential extensions, we should be able to extend those in some way, shape, or form to get what we're going for. Another thing that you're going to be able to also do at the end of the day is actually decrease the amount closer to center, move your points closer together, things like that. So again, we go to your heights tab, bottom height. Is that the selected contour? Is it stock center? Is it origin in this case? There's a lot of if, ands, or buts about it. Again, as you're seeing, is I've now gone to origin, which means at some point we start spiraling further down. I have to control everything based on ramp angle. Again, it's a little messy, but it does work at the end of the day. So again, you could have a maximum ramp step down amount, things like that, all based on that sketch that I drew, right? So again, we could go back to manufacture, design, I should say, get my points closer together. At some point, if I get too close, notice how they want to link together or overlap. So you're always going to fight that little bit extra, right? But this is just one way. There's a lot of ways to do stuff inside of Fusion. You tell me, Stuart, is this going to work or not? So again, now my tangential extension is respecting and overlapping because I've made my points so close together. And if you were going to simulate this, I'm completely upside down. I think this is a good one to close on, but I am going to go check the ticket system while this runs. You guys can watch it. Anybody else up? Questions? 5. All right, we're going to go ahead and we need to convert Stuart's into a ticket. And if you guys are blowing up chat right now, I have no idea. Here's that. Any other questions in the meantime? Boom. Solved. Who else had questions? There we go. Resolved. Back to chat. What do you think? Is that going to work? I think it would work. You do have overlap when you come back the other way. But as you're seeing this work down into the part, again, we need to adjust a few more things, but it's 100% working its way in. Now, it's not full 360 degrees around every time, but it is working towards center to be a part off kind of operation. Now, this is where Stuart's probably going to tell me that he meant to part off the hex, if I had to guess. I think this is a good stopping point. I don't see any more tickets coming in. I don't see any other questions in chat. I've seen people coming and going. Let's go ahead and swap back over. Again, one last time. It's not what you guys know. It's who you know. You know Fusion, or Fusion Phil over here at jitcadcam. With that being said, if you guys found something useful today, like what you saw, have any questions, feel free to leave a comment on this video. Feel free to send us a support ticket using the email down below, as most people have done. You can also, at the end of the day, always buy us beers and steak. You can move your Autodesk licenses over, and you can even, outside of that, request us for customs training in any way we can, and support on other things, not just inside the software, but machining in general, or maybe some network stuff. I've done a lot of stuff with Live Connects with Haas's and other machines. So with that, I'm going to leave you guys to it. Have a great rest of your weekend. If you're watching this over the weekend, thank you. And as always, man, I don't know, what else should we say at this point? I failed on Stuart's. I feel bad. I'm going to need a beer for that. But, oh man, you guys have a great one. I look forward to seeing you next week.